Welcome back, Algebra 2 students. We are in lesson 17 and we're going to talk about subscripted variables. Subscripted variables are just variables that we use to illustrate what it is that we're calculating a little bit better. So, for instance, we have a word problem that says the number of nickels and the number of dimes in a jar was 40. So there are 40 coins total. The value of those nickels and dimes was $2.50. So we can write two equations based on that. This is 17.1. Our first one is that the number of nickels plus the number of dimes was equal to 40. There were 40 coins. Our second statement is that the value of those coins was $2.50. So I can say 5 times the number of nickels because a nickel is worth 5 cents, plus 10 times the number of dimes because a dime is worth 10 cents, is equal to 250. Now the reason I'm not using a decimal here is because I'm not using a decimal here. And getting rid of the decimal just sometimes makes it easier to solve. So I can do this one of two ways. I can use elimination or I can use substitution. And I think I'm going to do it both ways just to show how you can do that. So I'm going to subtract the number of dimes from both sides. And I have the number of nickels is equal to 40 minus the number of dimes. And that is the value I'm going to use to substitute that in for the number of nickels here, because that's what the number of nickels equals. So 5 times 40 minus the number of dimes plus 10 times the number of dimes is equal to 250, not 200, 250. 5 times 40 is 200, minus 5 times the number of dimes, plus 10 times the number of dimes, equals 250. So if I combine these two, I get 5 times the number of dimes, and if I subtract 200 from both sides, then I get 5 times the number of dimes is 50. So if I divide both sides by 5, the number of dimes is equal to 10. So now I can use that to substitute back into here. The number of nickels plus the number of dimes is equal to 40. Well, if the number of nickels plus 10, because that's the value of the dimes or the quantity of the dimes, is 40, then there must be 30 nickels because I subtracted 10 from both sides. All right, so now I have the number of nickels and the number of dimes. And if you want to test the value, that's something I want to talk to you guys about. It's always a good practice to check your work before you try to type it in the system. Make sure that you have the right answer. And the way we can do that is by taking this value statement here and substituting in the values that we found. So 5 times the number of nickels, which was 30, plus 10 times the number of dimes, which was 10, should equal 250. So 5 times 30 is 150, plus 10 times 10, which is 100, and 150 plus 100 is in fact 250. So we know that we found the right answers and we can confidently type it into our system and enter it and make sure, that we do a good job of finding the solution before we frustrate ourselves trying to type different answers into Jupyter and it give us, a headache because we're putting the wrong answer in, or maybe the answer's in the wrong format, whatever the problem might be. If you're confident, if you've checked your work and you know the answer is correct, you can type it in with confidence and leave it there. If you know it's right, just let it take it, because I am the ultimate grader. I'm the one who's going to be looking at it. Let's move on to 17.2. For this question, we are just given a system of equations to solve. So we have, for 17.2, Rm, Tm plus RW TW is equal to 260. Of that, RM is equal to 40, RW is equal to 60, and TM plus TW is equal to 5. So we can substitute the 40 and the 60 in pretty easily. So we can put 40 in here, and we can put 60 in here, right? TM and TW not so easy. So I'm going to create a substitution value for TM by subtracting TW from both sides. So TM is equal to 5 minus TW. And that's what we're going to put in for TM. 5 minus TW. And then we'll just leave TW here. Okay, so now I can say 40 times 5 is 200 minus 40 TW plus 60 TW is equal to 260. When I combine these, I get that 200 plus 20 TW is equal to 260. I subtract 200 from both sides, and I get that 20 TW is equal to 60. If I divide both sides by 20, TW is equal to 3. Now I can find the value of TM, because TM, 5 minus 3, that's going to be equal to 2. So now I have all of the values necessary. But I do want to double check and make sure that this works out. So RM is 40 times TM, which is 2, plus RW, which is 60, times TW, which is 3, should be equal to 260. So that's 80 plus 180, and that is equal to 260. So we know we calculated correctly. Always, always, always check your work before you try to put it in the system. If you can get this correct, then you know you've done the problem well, and you know you have figured out what you needed to figure out, and you can have some confidence in leaving it in the system and knowing it'll get marked right. So let's talk about angle relationships. This is problem 17.3. We can devise problems about angle relationships that let us practice the solutions of two equations with two unknowns. And what we're going to do is find x and y. And here is the illustration. I have a parallel line to this one, and then I have a transversal. And so one of the things that we know about transversals, or that we should know about transversals, is that they create what's called alternate interior angles. And alternate interior angles just means that the opposite angles on the inside are going to be congruent to one another. So this one is congruent to this one, and then this one is congruent to this one. The other thing we know is that opposite angles have the same degree of measure. So these two are equal, and then these two are equal. Same thing down here. These two are equal, and these two are equal. So we have only two dimensions with 8 angles, right? So let's see if we can solve this. So we have 7x minus 2y, and this one is 50. And then we have down here that this is 5x minus 10y. All right, so what I know based on this is this angle is equal to this angle. So this is set to 50. So 5x minus 10y is equal to 50. So that tells me a value that I can relate to that. The other thing that I know is that this is a straight angle. We know that a straight angle is 180 degrees. So if this one is 50 then this one has to equal 130. So I can make that statement down here as well. 7x minus 2y is equal to 130. And what that does is it allows me to now multiply one of these to create a commonality that I can then eliminate. So I'm going to multiply, let me rewrite this one first. 5x minus 10y is equal to 50. I'm going to multiply this one by a negative 5. Negative 5 times 7 is a negative 35x. Negative 5 times negative 2 is a positive 10y. And a negative 5 times 130 is going to be a negative 650. Yes, that's right. So when I combine, this cancels, and then this becomes negative 30x equals negative 600. When I divide both sides by a negative 30, I find that x is going to be equal to 20. So now I have the value of x. So all I have to do is go back in here and solve for y. So I'm going to use this one just because it is a smaller x value. So 5 times 20, that's the value of x, minus 10y is equal to 50. So if 5 times 20 is 100 minus 10y, if I subtract 100 from both sides, I get that negative 10y is equal to negative 50. And when I divide both sides by negative 10, y is equal to a positive 5. So now I have the value of x, which is 20, and y, which is 5. Now what I'll do is I will go ahead and check that just to make sure. And I think I'm going to check it on this one just to use a different equation. 7 times the value of x, which is 20, minus 2 times the value of y, which is 5, is equal to 130. 140 minus 10 is indeed equal to 130. So I know I got the right answer. All right, so let's look at, actually that's it. That was our last problem. So that's all I have for lesson 17. If you have any questions, please ask. I am here to help, and I will see you in lesson 18.